Hello everyone. Today we're going to talk about how you can analyze the Kubernetes component security. And those components are pods, containers, and other elements of the Kubernetes architecture. So, as you already know, pods are actually the main component of Kubernetes and represent one or more components that share network. For that reason, their security is very important and it needs to be implemented in one of the first steps of the cluster design using security policies. So if you want to actually check out some examples on how you can apply the Kubernetes security policies, you can check out on Kubernetes IO pods security policy. You can see that now, even today, we're using use pod security administration and also third-party security plugins. So definitely feel free to check out specifically pod security administration and the pod security policy, since those are the core for understanding the security for pods. So according to official documentation, a pod security policy is a cluster level resource that pretty much controls some aspects from the pod security. So those security policies are normally defined with a pod security object, and using that object we can actually define conditions that the pod should meet in order to be accepted by the system. It also allows you to define the default values in fields that are not specifically assigned. So as you can see, to define pod security policy, you're using the manifest YAML file that would normally have the type of your object, the metadata, the specifications, and the supplemental groups, such as users, groups, and host ports. So even though the privacy policy is depreciated, it's actually important for you to see how a policy file or a policy YAML file looks like and how are the different fields defined. So the pod security policy will normally allow the administrators to control the containers in privileged mode, and to do that there are 4 fields that allow us to define the behavior of a container with respect to the access to certain parts of the host. And those fields are the host PID, which controls whether the pod containers share the same process space and the host. Then you have the host IPC, which controls whether the containers in the pod share the same IPC space, the host network that defines whether a pod can use the same host network space. It also implies that the pod would have access to a loopback device and the process running in the host. And finally, you have the field host ports that defines the range of ports that are allowed in the host network space. So this range of ports is given by the host port range. That is a field that has a min and max attributes that can pretty much define the range of the ports. The other key value is the volumes and the file systems, and this has volumes, which provides the list of permitted volumes that will not be read-only and will be able to write files there. Then you have the FS group that allows you to indicate the groups where to apply certain volumes. Then you have the field allow host paths, which specifies a list of paths that is allowed to be used by the volumes. And for example here, if you paste an empty list, that would imply that there are no restrictions. And finally you have the read-only root file system, which pretty much requires the containers to run with root file system in read-only mode. Then you have the users and the groups. And so the user groups can have the following parameters. You have run as a user that will specify which container will run inside the pod, and also run as a group which specifies which group ID of containers will run inside the pod. So here pretty much the difference is that if you run as a user, you just specify one container to run in the pod, while at the same time you can actually group certain containers, add an ID to them, and once you specify this ID, they can run in the same pod by a single reference. And finally we have the privilege and the capabilities. So for example, the privilege escalation will prevent from changing the user effective ID and will also prevent enabling extra capabilities, so your system will be more secured. On another side, the capabilities are pretty much series of super user privileges that can be enabled or disabled independently. So let's look at the fields for privilege and capabilities. So for example, the privilege escalation is defined by the allow privilege escalation field, and this specifies whether or not to set the security context of the container. By default, this parameter is actually equal to true to avoid any compatibility problems. Then you have the default allow privilege escalation, which allows you to set the default option of the allow privilege escalation. So those two parameters are pretty much dependent. So in the capabilities section, you have the allowed capabilities function, which is pretty much a list of capabilities that can be added to the container. So as you know, all the capabilities are actually added by default. So if this field is empty, this implies that you cannot add capabilities beyond the one that are already there by default. And then you have the request drop capabilities parameter, which is the list of capabilities that must be removed from the container. They will be removed from the default capacity group, and these capabilities should not be included in the allowed capabilities list. So for example, two very useful types of controls are the liveness and the readiness probes. So health checks are very important in Kubernetes, and for that reason it is a very good practice to perform liveness and readiness probes. For example, the liveness probes is used to check if the application is still running or has stopped. Kubernetes normally doesn't do anything if your application runs successfully, but it will actually launch a new pod and run the application if your application has been stopped. The readiness probe on the other side is used to verify that the application is ready to start to send traffic. So Kubernetes will stop sending traffic to the pod until it has health checks fails. That said, thank you very much for watching, guys, and I will see you in the next section.